Hi, in the last video when we left off, we were just about to start with sinusoidal functions. So essentially, when we talk about sinusoidal functions, we're talking about a sine or cosine function that has been transformed in one or more of these ways. So if you like, you can pause this video and go over just what the effect of these parameters have on your sine and cosine function. I am assuming that at some point you studied the transformation of functions. So you can pause and read this. Okay, so let's look at a GeoGebra application that I put together here. Essentially what we're going to do is we have a sine function and then we're going to go varying these parameters. So let's switch over to the actual application. As I currently have it set up, A has a value of 1, B a value of 1, D a value of 0, and of course C, we will vary the value of C, but currently its value is 0. As you can see, what we have here is our standard sine function running between -1 and +1. This is in radians, and as you can see here, one period is about 6.28 or 2 pi. Let's vary the value of C. To vary the value of C, all I do is move this slider left or right. So if I move it to the left, you expect this to move to the right. I have replaced the variable C with its value, which is currently 0. Let's increase the value of C, and you can see if I increase it, that's about 6.3. I've moved it 6.3, and of course I can move it to the right. Let me write the standard function in so that you can have some reference. So once again, I bring C back to 0, and then I move C. So the function that I'm displacing is the blue one. So I can move it to the left, and I can also move it to the right. I have moved it 5 units to the right, and so what we have here is x minus 5. I can move it 5 units to the left by then having it become x plus 5. This should not be anything new to you. F of x plus a is simply f of x that's moved either to the right or to the left, depending on whether or not a is positive or negative. Now we keep the value of a and b equal to 1, but c we make 0, and d is the parameter whose value will vary. So currently its value is 0. This red graph that you see here is your basic sine function, and f of x equals sine of x plus d is right behind it, and since d is equal to 0, it's perfectly overlapped by this red graph. Now what will happen when I make d positive? I believe you know that the y position of the graph will increase. So let's do that. So this is pretty straightforward. I just make this positive, and notice the y value increases. Alright, make it negative, and the y value decreases. So if I increase it by 1 to a value of 1, notice this point that was here at 1 is now at 2, and way down here, this point that was at at -1 is now at 1. Of course, I can also move it the next way. So we just want you to get us an idea of this. Notice this point was at 1, now it's at 0. This point was at -1, and now it's at -2. So we can vary the vertical position of our graph by simply varying this parameter here. Now let's turn our attention to the parameter a, also referred to as the amplitude of your sine function. What a does is affect the vertical dimensions of your graph. Let's increase the value of a. As you can see, it increases. So I'll make it, let's say, 2. The vertical dimensions go from 1 to -1 to 2 to -2. So I've doubled the vertical size of this graph. Of course, I can bring it down to 1/2 of its original size. So see, now it goes up to 0.5 and down to -0.5. Let's recall what happens if I make this value negative. So that's like multiplying this function by a -1. That causes the function to undergo a reflection about the x-axis. So I can make this -1. It has undergone a reflection. Right? So it went from being this way to now being this way. Of course, it can have many different values. So as long as it's negative, it'll also undergo that reflection about the x-axis along with a compression or expansion. So here it's been compressed and reflected. Here it's being expanded and or stretched and reflected. And over here it's I can compress it or expand it. So when you hear the term amplitude modulation, what is going on is that something can affect, you can have some kind of oscillation and you can have something affecting the amplitude. And then that variation in the amplitude can convey information of some sort. Let's now vary the coefficient of x. As you probably know, if this coefficient is greater than 1, what you will have is a horizontal compression. And if it's less than 1, you will have a horizontal stretching. You should also know that if this is made negative, there will be a reflection about the y-axis. So once again, to keep things simple, I've left a as 1, so there's a 1 that's multiplying this here. C is 0 and D is 0. So let's make B a little bit greater than 1 then. And as you can see, it's beginning to get compressed. So the period has been reduced. Notice that this value of B, the period is 1/2. So because I've multiplied x by 2, I have reduced the period to 1/2 of its initial value. As you can see right here in the graph, one complete oscillation of the blue graph occurs in half of the oscillation of the red one. So that means the period has been reduced to 1/2 of its initial value. Of course, I can also increase the period by reducing this to 1/2 of its initial value. So notice now, the period now is twice its initial value. We see 2 complete oscillations of the red curve for 1 complete oscillation of the blue one. So by varying this parameter here, I can vary the period. The inverse of the period is called the frequency. And so by varying this parameter here, what I'm doing is called frequency modulation. So you've all heard of FM. Let's see what happens when I make this, let's say -1. So let's make it 0 again. So you see at 0, not 0, sorry, at 1, that's the original function. Let's make it -1 now. I hope you can see that what has happened here is now a reflection about the y-axis. So take your time and look at it. This whole thing has been flipped around the y-axis. So these can have any value. Of course, it makes no sense for it to have a value of 0. But other than that, B can have any value. Alright, so we have looked at all of these individually. But we can have any combination of them. So I can take a sine function, for example, and displace it vertically, let's say by 1. And then I can give it some kind of, I can change the frequency to twice its initial value. In other words, the period is now 1/2 of what it was before. And then I can displace it horizontally. To displace it horizontally, you have to be careful now because you have to isolate the B. So you have to say B times, in parentheses, x plus some number. If I make C 5 now, the horizontal displacement will only be to the left 2.5. So you can see it moved over to the left 2.5. So why is this? It's because now what we have here is 2 times, open parentheses, x plus 2.5. And so it's x plus 2.5 that you need to look at. So that's why when we write the B and the C, the horizontal shift becomes C over B. So think about that and make sure you understand it. And of course I can change the amplitude. I can, let's say, make the amplitude smaller. So the function now is going to be 0.3 2x plus 5 plus 1. So let's write the function out here. And so there is the function now. A vertical compression to 0.3 of its initial value, a vertical shift upward of 1, a shift to the left of 2.5, and the period is reduced to 1/2 its initial value. Okay, so that brings us to the end of this video on sinusoidal functions.
One small note before we leave. The previous discussion also applies to the cosine. So for example, this is our standard cosine here, and this is our transformed cosine. Note that one difference between the sine and cosine is that the sine, while it's an odd function, of course, the cosine is even. So the reflections about the y and the x will definitely not be the same. So let's take a look at that briefly. So here is our cosine, and let's make b -1. So that will give us a reflection about the y-axis. Notice we see no difference. Why? Because now we're dealing with an even function. However, if you make a negative 1, this will give us reflection about the x-axis, and so we see here. So be aware of these subtle differences between the sign and the function and how these functions are affected by these parameters, especially when we make a and b negative.
Thanks for your kind attention. Bye for now.